So here we're being asked about the bond angles at a couple different atoms. Now for this, being asked a bond angle is really like being asked a geometry, because once you know a geometry, you know a bond angle and vice versa. So we start here with C1. You note here that C1 is linear. You notice that there's no lone pairs on the carbon, remembering that in VSEPR, it's really important to show those lone pairs because those influence the molecular geometry. No lone pairs, straight line, linear, and 180 degrees, because linear always has a bond angle of 180. We move now to the other structure. Now I'm going to show the lone pair on the nitrogen. And then I remind you that this particular type of functional group has a really important resonance structure, which I will draw here in red. So here we show the nitrogen like so and like so with that negative charge, and I'll show all my lone pairs for good practice and a positive charge down here at the end. Now, since this nitrogen has this major contributing resonance structure, as a reminder, this functional group here is called the amide. And when we see that amide, we know we have this important resonance structure. And when we have this important resonance structure, it affects the geometry, it affects the bond angle, it affects the hybridization. This here is going to be trigonal planar. And since it's trigonal planar, the bond angle will be 120 degrees. So again, show your lone pairs when you're dealing with VSEPR, as those do affect the geometry. And beware the amide. Watch out for this functional group with this major contributing resonance structure, as this affects the hybridization, the geometry, and for this question, importantly, the bond angle.